question number 1. And the year is October, November 20, paper 22. Going to start, you have to take and complete the columns in terms of scalar and vector quantities. For example, acceleration, you know that is the vector quantity. Density and temperature both are scalar, while the momentum is also a vector quantity. Vector quantity means the physical quantities which are direction dependent. Now for part 1, this B. A toy train moves along a straight track. In the figure 1.1, its distance d versus time is shown. So distance d versus time. The most important thing is the distance time graph give us information about the speed. It means describe qualitatively the motion of the train between 0 and 1 second. This is 0 and 1 second. So for this, the slope is positive and decreasing. It means when the slope is positive and decreasing, decreasing means it's becoming parallel with x-axis. So the slope is decreasing. When the slope is positive and decreasing, means the speed of the body is positive and decreasing, or you can say the velocity is positive and decreasing. When the velocity is v is decreasing. I'm just mentioning for your information, you have to write the complete details. V is decreasing, and you can say that the body is going to decelerate. And the velocity decreases means the brakes are applied, or some opposing force is acting on the body and it is going to decelerate. Hopefully you got it. Now you have to determine the speed at 2 seconds. And this is the point where you have to get the speed. The most important thing is at this point the slope is uniform. So the gradient is uniform and the gradient will give you the answer. Suppose we are going to start from this point and end it at this point. These are the straight lines. And now for the time we have these 2 points here. And for the distance we have these 2 points. Clear? By using these points, you can find the slope, and that slope will give you the speed. For example, the point somewhere over here is 0.56. So 0.56 minus the distance at this point is 0.20 divided by the time is from 1.5 to 3. It means it's 1.5. By solving it, you can get the answer, and the answer is 0.24. 0.24 meter per second is the answer. Now, the last part of the question. The straight section of the track in B is a part of the loop now. Now this is considered to be a loop. So the train have one tab for the one lap of the loop. Yes, it is. Okay. State and explain the average velocity. You know that the average velocity is the total displacement over total time. As suppose this is going to start from point A, and after this one complete lap, it comes at point A again. So the total displacement is 0. If the total displacement is 0, then the average velocity is 0. So um, uh, it's 0 because The total displacement is zero. Thank you very much. Bye.